Welcome back. This is another course. In this course we'll be taking a look at Cisco ISE. We will take a look at what the product is, why it's needed, its core functions or capabilities, its architecture and deployment methods, and how to administer Cisco ISE. It's going to be a bit of a crash course on Cisco ISE, so it's a couple of hours long. We will have a look at the latest 2025 updates as well, what is new in Cisco ISE, and it's a step-by-step tutorial designed for all skill levels. So let's get straight into it. What is Cisco ISE? Cisco ISE is the central control plane for network security. It enforces who gets in, what they can access, when, where and how, based on real-time context, posture and identity. It does it at a scale intelligently. So who is the user, for example? What device are they using? When and where are they connecting from? And how are they accessing the network? So these are some key questions Cisco ISE can take a look at for us and compile all of this together before it takes action and does something. So with this context, organizations can define and enforce access policies, granting the appropriate level of access based on any combination of these factors. So it acts as the brain of your network security. It ensures trusted users and devices access network resources across wide, wireless and VPN environments, fitting into a zero trust framework. ISE unifies network access control, authentication, authorization, posture assessment, profiling and guest management. So it unifies it all. It can do all of this in one single solution. Now let's take a look at some key capabilities of Cisco ISE. So Zero Trust Backbone. These are very high level, by the way. We'll break it down further in the next few slides. Zero Trust Backbone. It serves as a central policy engine for continuous verification and adaptive network segmentation, foundational to a zero trust architecture. And then there's the context-aware access, which applies least privilege controls based on real-time context, user identity, device posture, location and threat intelligence utilizing ACLs and SGTs. And then the next high level capability of the three is comprehensive visibility, which provides endpoint visibility with deep device profiling. This is 1,000+ types of devices. Posture assessments as well, compliance checks. So posture assessment is to check if the device is in the correct posture, it's got the correct operating system fixes, for example, and it's got some very good detailed guest onboarding capabilities as well. Now let's take a look in a bit more detail at the core capabilities. So the top left one is authentication and authorization, and in brackets we call this AAA. Actually it's missing accounting, so this stands for authentication, authorization and accounting. So this handles Radius and TACACS protocols for comprehensive user and device authentication, plus administrative access control as well. So administrators gaining access to network devices, for example, and it supports multiple authentication methods, including 802.1x, MAB, which stands for MAC address bypass, web authentication, VPN, and it enables fine-grained policy enforcement based on user groups, roles, time and location. Then we have device profiling, and this automatically identifies and classifies network devices such as IoT sensors, Internet of Things sensors, printers, mobile devices and corporate endpoints. It uses advanced network behavior analysis, protocol detection and telemetry data with an extensive library of predefined device profiles for accurate classification. And then there's, on the bottom left, posture assessment, which evaluates device health and security compliance before granting network access. So it checks the device. For example, it checks it for antivirus status or OS patch levels or disk encryption and other security configurations. So you can configure it to check certain aspects of the device. And it offers both agent-based and agentless assessment options, with detailed compliance reporting and automated remediation capabilities. And the last one in this slide is continuous compliance enforcement, which maintains ongoing device compliance monitoring after initial access is granted. It continuously monitors device posture and automatically applies remediation actions or access restrictions through dynamic policy updates and network device controls to ensure solid or sustained security. Now here's the next four. This is the last slide on core capabilities of Cisco ISE. So it offers guest and bring your own device management. So it streamlines guest access with multiple registration options, including self-registration, so guests can register themselves. There's also sponsor-based workflows where the guest is sponsored by someone, and it provides mobile device portals. It provides secure certificate provisioning and onboarding processes for both guest users and bring your own devices with VPN access integration. Then there's security group access, which is TrustSec. This enables dynamic network segmentation through security group tags for granular policy enforcement. It delivers microsegmentation capabilities with inline enforcement and centralized policy management, and creating security network zones based on user identity and device trust. So with security group access, it automates dynamic network segmentation using security group tags for group policy enforcement. So this is network segmentation, SGT-based microsegmentation via inline enforcement and central policy. Then there's the ecosystem and pxGrid integration, things that integrate with Cisco ISE. So it automates threat detection and containment through seamless integration with Cisco security tools and third-party solutions. And it leverages pxGrid and pxGrid Cloud for real-time threat intelligence sharing and security response across the entire network infrastructure. So pxGrid automates threat containment with other Cisco and third-party tools via pxGrid and pxGrid Cloud. Then it's got a built-in certificate authority. So this issues and manages digital certificates for both devices and users, and it supports EAP-TLS and other certificate authentication methods. Now, something a bit more interesting. What is the common use case for Cisco ISE? What are companies today using Cisco ISE for? And the very top one is network access control, which ensures that only authorized users and compliant devices can connect to the wired, wireless or VPN network. NAC enforces policies based on who the user is, what device they are using and where from. The second most common use case is for its identity-based access policies. So it uses protocols like 802.1x, MAC authentication bypass and WebAuth to authenticate devices and users. And identity-based access policies does the assignment of dynamic VLANs, security group tags, and ACLs based on policy results. Then the third most common use case is guest and bring your own device access. So it provides secure guest Wi-Fi portals and self-service onboarding for personal devices. It's very common in universities, hospitals and corporate campuses. Next, for the fourth one, is posture assessment. So it checks device health. So it posture assesses the device. So it checks for device health, antivirus patch level disk encryption, and so on before granting access. And it optionally blocks or quarantines non-compliant devices. So you can block them if they're non-compliant. Then for number 5, it's device profiling. So it can identify devices like VoIP phones, printers, Internet of Things devices, and this is automatic even without the user logging in. This is essential for campus environments when it's full of unmanaged or headless devices. So you can imagine campus environments, you are getting visitors coming in and out of the buildings or the campus, and there's many devices connecting to the network. So they are unmanaged, and device profiling helps you profile the devices, helps you identify the devices. For number 6, we've got TrustSec segmentation. So tags traffic using SGT, security group tags, and this enforces scalable access segmentation across the network without relying solely on VLANs or firewalls. So this helps apply zero trust principle within the local area network. And the last one is the integration hub, pxGrid. So this shares context with firewalls, even SIEM solutions, EDR, MDM, mobile device management, and CMDBs to coordinate enforcement. For example, quarantining a compromised device detected by an EDR, like Cisco Endpoint or CrowdStrike. And you would get ISE typically deployed in environments such as corporate campuses, universities, and educational networks, hospitals, healthcare environments, government buildings, airports and transportation hubs. And in these networks, users and devices constantly move around, making identity-based control far more effective than static IPs or VLAN approaches. So that's why the identity approach is a lot more crucial and effective. Cisco ISE enables secure access by collecting rich contextual data for every connection attempt. It helps organizations answer key security questions like who is the user, what device are they using, when and where are they connecting from, how are they accessing the network, and then with this context, Cisco ISE applies dynamic policies to grant the user appropriate level of access, ensuring users and devices only get what they need and nothing more. So that's why we can see who, what, where, when and how before Cisco ISE applies policies. And then ISE gathers this data, of course, from sources like DHCP, NetFlow and device telemetry, while integrating with identity systems such as Active Directory and LDAP. It can also evaluate posture and compliance through integration with supported endpoint security tools. Now this diagram illustrates a basic Cisco ISE architecture and workflow for network access control across a network. So starting on the left, we can see endpoints. These are the devices trying to access the network. We can see tablet via a wireless LAN and a laptop via a wired LAN and a remote laptop via a VPN tunnel. These are users trying to connect to the network either wirelessly or via a LAN or remote via a VPN. And number two, we've got network access devices. These devices control access and enforce security policies. So we've got firewalls that control VPN or remote access. Then we've got access points or wireless LAN controllers, AP or WLC, which manage wireless connections. Then we have switches, which provide LAN connectivity with authentication capabilities. They initiate authentication requests using protocols such as 802.1x for supplicant-based authentication or MAC address bypass for non-supplicant devices. So these are devices that do not support 802.1x like printers. And then there's WebAuth for web-based login. In the middle we have the network, or it can be a campus network. This is the network where all these access control requests follow through. And then a little bit on the right we have policy enforcement via Cisco ISE. Cisco ISE in the middle right is the central NAC engine that makes decisions. Again, based on who is connecting, what is connecting, the device type, how they are connecting, wired, wireless or VPN, posture compliance status, have they got AV installed, is the OS patched to the expected version. And then ISE receives authentication requests from access devices and decides whether to allow or deny access, what VLAN or ACL to assign to that device, whether remediation is required. ISE will work all of this out as well. And then we've got the identity and policy backends, which is the ones on the right are the infrastructure services. ISE integrates with the backend services to validate identity. So AD for user credentials, that's Active Directory, or LDAP for directory lookups or alternative identity sources. CA, which is the certificate authority for certificate-based authentication. And once the device or the user is authenticated and authorized, users or devices are granted access to protected resources, for example, applications, data stores and services. Next is the integration and ecosystem. So what integrates with Cisco ISE? Cisco ISE integrates with Cisco and third-party tools to deliver unified access control, visibility and threat response. So looking at the first one is Cisco DNA Center. ISE shares identity and policy context with DNA Center, and then DNA Center uses this information to enforce segmentation and respond to threats by adjusting access dynamically. So it's a dynamic way of adjusting threats based on the security group tags. So for example, if ISE detects a compromised device, DNA Center can automatically quarantine it by changing its VLAN or access permissions. Cisco DNA Center allows you to manage an environment from a single dashboard, by the way. ISE works with DNA Center to provide secure zero trust networking. Next is Cisco AnyConnect integration. AnyConnect collects posture and compliance data from remote endpoints. So AnyConnect you install directly on the remote endpoint. It enables access decisions based on AV status, OS version and disk encryption, etc. And it supports secure remote access remediation. So when a user connects remotely, AnyConnect collects endpoint data, again antivirus and so on, and it sends it to ISE. ISE uses this data to enforce posture-based policies, allow or deny or remediate. Next is Secure Network Analytics. It used to be called Stealth Watch. And ISE shares identity context, user, device and location with Secure Network Analytics. The analytics platform, by the way, detects anomalies and triggers ISE to restrict or revoke access. So when the analytics platform finds an anomaly, it will ask ISE to enforce a particular access based on what it's found, based on its policies. It enables automated threat containment. It provides real-time network traffic monitoring and anomaly detection. Now coming on to pxGrid. pxGrid enables real-time context sharing with security tools. So it's Cisco's context sharing framework that connects ISE with external systems like firewalls, SIEM, EDRs and NAC solutions. It works on publish-subscribe model. ISE publishes identity, posture and session data. So Cisco's context sharing framework that connects ISE with external systems like firewalls and so on. ISE publishes identity, posture and session data. It integrates systems, subscribes to updates and reacts accordingly. For example, a firewall can block a device instantly if ISE reports it as a non-compliant device. Right, so that's enough about integration and an overview of ISE. Let's now have a look at the ISE web GUI interface, so how we administer ISE using the web GUI. And then we'll move on to a deeper dive into ISE components and how to best deploy ISE. I'm going to do a quick demo of the dashboard of Cisco Identity Services Engine. So we are on Cisco dCloud. Cisco dCloud is Cisco's online platform that provides ready-to-use virtual demo environments for learning, testing and showcasing Cisco solutions. So we can get onto Cisco ISE using Cisco dCloud. If I log in, when I log in, it gives us the dashboard. This is the first screen we come to. So it gives you a real-time view of who and what is connecting to the network, how they are authenticating, and through which network devices. So let's have a look at the top section here. This section here provides a quick summary of the network endpoints and authentication status. So we can see total endpoints as 21. The total number of devices, wired, wireless or VPN, seen by ISE. Then we've got active endpoints. How many are currently active and connected? Next is rejected endpoints. So devices denied access due to failed authentication or policy violations. Anomalous behavior, devices behaving. These are basically devices that are not behaving or behaving unusually, which can be policy or traffic anomalies. Authenticated guests. This is guest users successfully authenticated via the guest portal and so on. So we've got bring your own device endpoints here as well. Then we've got some panels, authentication panel, network devices, endpoints and a few down here as well. So the authentication panel shows how authentication requests are distributed by identity store where credentials are verified. So we can see AD sudoku is likely an active directory service. Internal endpoints. So this helps demonstrate which sources users are authenticating against. For example, corporate Active Directory versus internal ISE database. If we move on to network devices, this displays network access devices communicating with ISE. So it shows network devices. So these are network devices communicating with ISE, and this gives visibility into which switches, routers, it could be firewalls or VPN gateways, are performing authentication with Cisco ISE. Next we have the endpoint panel. By the way, there's also these tabs you can scroll across as well for further information. But going back to endpoints, this is the breakdown of endpoint types. Microsoft Workstation, Apple devices, mobile devices, Cisco App Catalyst, 9120AX, Cisco device, Cisco Meraki device, Cisco IP phone, HP printer and others. So it demonstrates ISE profiling, how it classifies devices on the network automatically. Now if we scroll down a little bit more, this shows the number of bring your own device endpoints connected. Here we only have the one device, a workstation that's been onboarded through ISE's bring your own device portal. So it displays the number and types of bring your own devices, endpoints registered or seen on the network. We only have the one workstation. So it helps administrators track personal or unmanaged devices that users have onboarded. It's useful for ensuring compliance with company policies. For example, posture checking before access. So making sure it's got the right level of patch levels and antivirus and so on. Next is the alarms panel, which lists alerts or system notifications. It's useful for detecting authentication failures, misconfigurations or policy issues. So alarms that you need to be notified about. It displays active or recent system alerts generated by ISE. So for example, we can see profiler SNMP request failure. It indicates SNMP profiling requests failed, possibly due to a network device unreachable or misconfigured. Misconfigured supplicant detected. This is an informational message about a misconfiguration. AD machine TGT refresh failed, which is Active Directory ticket refreshing issue. It's common when AD integration is not fully synchronized. And then we've got the severity on the left hand side. So we can see this is a warning, but you can also have information, critical, and so on. And then these are occurrences, and then this is when it's last occurred. So the alarm widgets highlight system issues and warnings. It helps admins quickly spot issues. And system summary. So this shows overall system health. For example, number of ICE nodes here, 4 nodes. So it's showing that we've got 4 ICE nodes in here. And the performance metrics. So it provides a quick health and performance summary of your ICE deployment. It lists 4 nodes in the ICE cluster, and the one displayed is this one here, dcloud ICE sim inst ICE -3, and the bar chart shows key metrics such as the CPU, memory usage, and the authentication rate. So the purpose is to monitor system resources utilization and node performance in real time. It helps ensure nodes are healthy and not overloaded. So you can see your nodes are not overloaded, overutilized. And you can of course click many of these to drill down further. So I accidentally just drilled into that one then. But it brings us to the health summary. So chart time versus CPU utilization. Noted no data found. And one thing I forgot to mention, this is a simulated environment. Not all data is consistent. So we're not going to find real life data in this environment. Not with this particular setup. So if we go back to the dashboard on Cisco ISE, now we've got the left sidebar, and these icons are the main navigation areas in the ISE solution. So each one groups specific functions and views for managing the NAC solution. So we first have bookmarks. You can start to create your favorite bookmarks in here. We've seen the dashboard. Of course, you can manage the dashboard from here. So you can add new dashboards from here, add dash alerts, you can export it and so on. But on the left, the next one down, we've got context visibility. This is real-time visibility into what's connected to the network. Again, we're going to have a look at this later on in the course. But it shows devices currently on the network, users and their authentication status, device types, profiles and locations, health and posture compliance, if that's integrated. And it's obviously useful for identifying who and what is connected on your network, and it detects unauthorized and unmanaged devices. So this is your monitoring and visibility dashboard for users and devices. Then we've got operations. We can see we've got quite a lot more options in here. And this is systems, operations and troubleshooting as well. It includes the live logs, live sessions, real-time authentication and authorization logs. It has reports. These are historical reports on access, failures and trends. And it has live logs not only for Radius, so these are Radius live logs and live sessions. It also has TACACS live logs down here and live logs for the Threat-Centric NAC. But some of these are self-explanatory anyway. We've got troubleshooting tools here, diagnostic tools, download of logs, a debug wizard, and we can browse the settings, monitoring, log analytics and so on. We've also got adaptive network control. So this is dynamic access control mechanism in Cisco ISE that continuously monitors, evaluates and adjusts network access based on changing conditions. And we can see that from here as well. But moving on to policy, this is where you write your actual policies. So the policies based on what the company dictates, which are called access control policies. And in here we have authentication policies, how users' devices are authenticated. For example, Active Directory or certificates. We also have authorization policies, which is what access they get within the network. In here we can specify the authorized VLANs they can get access to, or we can provide it with some ACLs, access control lists, and downloadable access control lists. We've also got profiling and posture policies, which classify devices and check for compliance. So in short, this is where the rules live. How ISE decides who gets access and what they can do. Next is administration. So there's a lot of options in here. We can configure and maintain the ISE system itself. For example, deployment settings. We may as well click on one of these. Let's click on deployment. We can see tabs at the top as well. Licensing, certificates, logging, maintenance, upgrade, checks, backup and restore, admin access settings. So you may get the idea. We can see the deployment nodes in here. We can see the roles they play. Primary, secondary. It tells us about their personas. Administration, PAN, monitoring, pxGrid, policy service nodes, and so on. So these are the different nodes. But going back to the main administration menu, so you can see all of the options in here. So deployment settings again are for ISE nodes, licensing and certificates, for configuring and maintaining them. Identity management, for adding users, groups and identity sources. Network resources, these are all of the network devices. And we can group them as well, network device groups. Network device profiles, external, radius server sequences, NAC managers and so on. But we can see the network devices here. We can see this is an ASA VPN device, its IP address. The profile name. We can see it's a Cisco device and we can see the services it provides. Location, type and so on, VPN head end. And we can see all the types here, switches, wireless LAN controller. And we can add network devices from here. So if we go back to the administration page, this is where you manage network resources. And we can see network device groups is here as well. Two different ways of getting access to some of these services. And of course, system settings is for logging, backups and integration with external services, ADL, DAP and so on. So in summary, administration is for the back end, where you configure and maintain the ISE infrastructure. And then we've got work centers, and these are specialized task-focused modules tailored for specific use cases. For example, guest access for managing guest portals and sponsor accounts, or bring your own devices for onboarding with personal devices. TrustSec for managing network segmentation and security group tags. I'm going to go into TrustSec in a bit more detail if you are interested in that piece. Just a high level overview of what TrustSec is and all the components around the Cisco Catalyst Center. And pxGrid for integration with external security tools for data sharing. So these are solution-specific workspaces that simplify configuration for features like guest, Wi-Fi and bring your own devices. If we go back to dashboard, and we can see on the top right we've got some more icons here. So we've got the magnifying glass for global search across ISE dashboard. So it lets you quickly find users, endpoints, devices, policies or configuration items. It saves time instead of navigating through multiple menus. So it's a quick way of finding anything on ISE. The launch pad. The launch pad, this is quick access launcher to ISE features or external Cisco tools. Or you can call it the rocket icon, opens the launch pad. So it's a shortcut to the main ISE modules or external integration for quick navigation. Question mark is for any help. So it provides access to help documentations and support options. Then we've got the notification or bell icon for any system notifications and alerts. And then you've got your user account profile. So it shows which users logged in. It provides the options to log out, change password or view your user details. And that's a quick overview of the ISE dashboard and the ISE system as a whole, where you configure different parts of the ISE system. We will drill down further later on in the course on different parts of ISE. Before we get into the deployment options and all the good stuff on Cisco ISE, I wanted to cover off some terminology. Because some of the terminology, in particular around DNA Center, is quite confusing. It's actually not called DNA Center. They've actually changed the name for a while now. It's called Catalyst Center. So Catalyst Center and TrustSec terminology. So Cisco Catalyst Center, formerly DNA Center, is a centralized network management and automation platform. So it provides design, policy, automation and assurance across campus and branch networks. Think of it as a control tower for the enterprise network. So that's what Catalyst Center is. Cisco ISE, Identity Services Engine, is an identity and access control platform. It authenticates users, devices and assigns them a security group tag. Think of it as a passport office of the network. Now, security group tags These are labels, or you can call them tags, that classify user devices into roles. For example, finance, guest, sales, HR, and so on. The tags replace IP addresses or VLANs. They travel with the traffic, independent of IP or VLAN. You can think of them as digital passports that define what you can and cannot access. Cisco TrustSec. This is a framework that uses SGT's security group tags for software-defined segmentation. They are enforced by switches, routers, firewalls, and policies say which groups can talk to which groups. You can think of this as law enforcement systems for passports. And the last terminology is SD access, software-defined access. This is a Cisco architecture that brings automation and TrustSec segmentation together. It runs on top of DNA Center and ISE, and you can think of this as self-driving network where access and security are automated. So these are the terminologies I wanted to cover off, so you have more of a clear idea what each one is. Now here's a standard architecture diagram illustrating how Cisco Catalyst Center fits within a network. At the top you can see Cisco Catalyst Center appliance, either physical or virtual, acting as a central management and controller entity. It communicates southbound with network devices, switches, routers, wireless controllers, firewalls, and so on, using protocols like RESTconf, NetConf, SNMP, SSH, or Telnet. Cisco Catalyst Center manages a wide variety of infrastructure through these interfaces. Northbound, it offers APIs and graphical dashboards for tasks like policy creation, network design, telemetry monitoring, and scripting, letting you build tools or integrate with other systems. Essentially, Catalyst Center delivers a single pane of glass for managing network design, automation, policy, and analytics. So this might be an interesting one. Catalyst Center with and without ISE. Using Catalyst Center when ISE is used. These are the following benefits with ISE. Cisco ISE isn't strictly required for Catalyst Center to work, but if you want the full feature set, especially security group tags, role-based access control and software-defined segmentation, then you need Cisco ISE. So when is ISE used? It's used for user device identity-based policies, which is security group tags, TrustSec, 802.1x authentication, dynamic network segmentation, so policies follow users wherever they connect, and it integrates with Active Directory for automatic tagging. And with Cisco ISE you can use it for guest access, posture checking, and bring your own devices onboarding. So this is effectively when you're using Catalyst Center for security and automation together. Now using Catalyst Center when ISE is not used. So when ISE is not used, DNA Center is still useful without ISE, especially for these things down here. Automation, push configuration, VLAN changes, firmware updates to hundreds of devices or even more at once. Monitoring and troubleshooting, so AI driven assurance. It provides network health dashboards and path trace, which is a feature to trace the path within the network. And the last one is inventory and compliance, so you can see all devices, track software versions, check against Cisco advisories. I'm going to scan over this slide, authentication and encryption protocols. Cisco ISE supports multiple authentication and encryption protocols to secure access at all layers. So it supports certificate management, which issues and manages digital certificates for users and endpoints, where ISE acts as a certificate authority, and the certificate management system issues and manages digital certificates for users and endpoints. Then there's 802.1x, an IEEE standard for port-based network access control. ISE authenticates devices before they can access the network using radius EAP methods and works with wired, wireless and VPN connections. Easy Connect, an alternative to 802.1x for environments where 802.1x isn't feasible. It uses Active Directory logins and network device info, IP to MAC mappings, for example, to assign dynamic VLANs or security group tags. It's easy to deploy for printers, VoIP phones and unmanaged devices. It uses passive identity, for example, AD login, WMI or syslog, plus fallback methods like MAB, MAC address bypass, so that when the user logs into Active Directory, ISE can correlate the machine's network connections with the user identity and then issue a change of authorization to the switch to adjust access. It's less strict than 802.1x, but easier to deploy in certain scenarios. Then there's MACsec. It provides encryption at layer 2, the data link layer, so it secures traffic on the wire between the devices. It works with 802.1x to ensure identity and data confidentiality on the network. So MACsec provides encryption on wide links layer 2 between devices, switch to host or switch to switch, for example. It ensures confidentiality, integrity and origin authentication of Ethernet frames. Cisco supports MACsec on newer Catalyst switches like the 9200, 9300 and so on. Also, certificate-based MACsec is supported, so instead of pre-shared keys or PSK, the device can use certificates. Then there's TACACS Plus for device administration. So Cisco ISE can act as a TACACS Plus server, controlling who can access network devices, switches, routers, firewalls. Again, this is for administration purposes, to administer the devices. And it enables role-based CLI access control. So I'm back on the ISE portal, and what we can do is have a look at some authentication type stuff. So let's have a look at some live authentications. And the way we do this is we go to Operations, Radius Live Logs. ISE lets you view Radius authentication to your network in real time using the live log capabilities. This lets you see what's coming in. You can also drill down further if you wanted to see if anything is failing as well. So you can see what's failing and why it's failing. So we get to the Radius Live Logs. You can click any of these as well. So you can see 13 misconfigured supplicants failing to connect, or misconfigured network devices, or Radius drops, or clients that have stopped responding. But also down here we can see the information about who, what, when, where and how subjects were authenticated to the network. So for example, Grace Smith at this particular time here, authentication passed, and you can see further details in here by the way as well. I'll click that in a second, but you can see what Grace Smith was using, the endpoint, so the MAC address here. It was a mobile device and it hit this particular authentication policy. And then if we click the details, so this report contains sections presenting authentication details, endpoint attributes and authorization results. So again we can see the overview, event, authentication succeeded, the name, endpoint ID and so on, authentication policy, authorization policy and authorization results. We can see authentication details down here, and on the right hand side, so it shows you here what the identity store was that we authenticated against. This is an Active Directory server by the looks of it. There's too much detail down here to cover off, but you can see all the details under authentication details, like the authentication method, .1x, authentication profile and so on. And on the right hand side here you can see all the steps ISE completed when evaluating its policies for an endpoint. So ISE went through all these steps when evaluating the policy for this particular endpoint, and you can see at the end it was a success and it's been accepted. So ISE uses the Radius protocol to perform the AAA services, authentication, authorization and accounting operations to communicate with the network access devices. In the authentication phase, ISE validates the user credentials against the identity source. The identity source can be internal to ISE or it can be external, such as Active Directory, ODBC, SQL databases, LDAP and so on. After the authentication succeeds, ISE continues to evaluate a set of authorization rules that will determine the access level to network resources a particular user or endpoint has. For example, access levels are VLAN assignments, ACLs, dynamic access control list, security group tags. The structure that contains the access level items is called authorization profile in ISE. At this point, a session is established and the accounting phase begins, allowing the session to be managed and monitored in ISE. So the reason I'm giving you that background information is because ISE needs identity sources to be able to authenticate the user against. So identity sources are where the user information is stored. For example, it stores credentials, attribute group, membership and so on. This information can be used in multiple ways in ISE to define the appropriate network access level for a particular user or device. Two of the most common user ID sources are Active Directory and Entra ID. So if we go to Administration External Identity Sources, so we had seen this one earlier on for that particular user, Grace authenticated against this identity source, and we can click it from here. And then we can click on the Groups tab to see groups ISE is importing from AD, which can be used in the authorization rules. So you can see all the groups ISE is importing. So you can see contractors, domain users, domain computers, developers, employees, and Internet of Things. At the bottom we can also see the REST ID if I break that down. This is where the integration between Entra ID, which is Azure Active Directory, and ISE is defined. So we can select Azure AD just to have a look at the configuration in here, and we can see how this is configured. So we can see the tenant ID, the client ID, a client secret password. We can see a couple of groups in here, and these are the user attributes. Now instead, if we go to policy elements and results, we can discard the changes. Authorization profiles contain a set of rules or instructions that are sent to the devices. They are the network access devices, the switches, routers and firewalls, wireless devices and so on, to enforce the network access level for a user or endpoint and enforce the authorization correctly. So we can hover to authorization here and have a look at authorization profiles. And here we have all the authorization profiles. One in particular is employee access. Let's click on this one. An authorization profile defines a set of network permissions or policies applied to a user or device when specific authorization rules are met. For example, after successful login by an employee. So you can think of this as a network access recipe that determines what kind of access endpoints get. Now we are in the employee access profile, so the name employee access, this is just a logical name to identify the profile. Of course you can give it a description, and access type. So access accept grants network access, and access rejects or denies network access. So it tells ISE what to instruct the network device, like the switch or the wireless controller or the VPN, to do when this profile applies. Network device profile. So this defines the vendor or type of network device, so Cisco, Aruba, Juniper, HP, Motorola and so on, that ISE communicates with. And this is because each vendor uses different radius attributes, so ISE tailors the policy enforcement format based on the selected device profile. Service template, this is a checkbox to reuse a predefined configuration template. This simplifies administration by allowing you to apply a group of settings to multiple profiles instead of configuring each manually. We'll skip these, but the next one, track movement, this tracks the device as it moves across the network. The purpose for that is to ensure the user's access remains consistent when roaming. So they're all very useful features. Suppose we'll go through them. Agent posture enables posture assessment, like checking for antivirus, patch level and so on, without requiring the ISE AnyConnect agent. Passive identity tracking. So this allows ISE to collect user identity information from external sources like Active Directory or syslog, or even firewall events without active authentication. Now if we scroll further down, we can see common tasks. There's quite a lot in here. So these fields control the network permissions and enforcement actions that ISE tells the network device to apply once a user or endpoint has been successfully authenticated. So the common tasks, like dynamic access control list. Sorry, it's not dynamic, it's a downloadable access control list. I always get confused with that one. So this is a downloadable access control list. It's a security policy that ISE sends dynamically to a network device like a switch, wireless controller or a VPN, for example. Instead of manually configuring ACLs on every switch, ISE pushes them automatically per user or session. And the purpose is to control what traffic is allowed or denied after authentication. So for example, employees allow all IPv4 traffic, and then it could be guests only allow web access, and for this it could be a different set of downloadable access control lists to permit HTTP and HTTPS only. And then maybe for contractors it could be restrict to a specific server, so allow to a specific VLAN. And then there's IPv6 DACL name. So this is similar to the above, but for IP version 6 traffic. ACL filter ID, instead of using a downloadable access control list, this option references a static ACL that's already defined on the network devices. So if you already have static ACLs defined on all the network devices, let's say for example on all the switches, you can use this instead, but it is for legacy setups when you prefer not to push policies dynamically from ISE. It's not scalable. It's always recommended to use the dynamic one, but I'm sure there's plenty of use cases to use it if you cannot use the dynamic one, for example. And you've got lots of other common tasks as well down here. So there's others as well. Security groups, VLANs. You can click them and then you can see their settings within each one. Web redirection. So if you're redirecting them, and there's plenty of others. So again, these areas provide predefined, commonly used authorization controls. These directly affect what the user device can access on the network. And the bottom bit is advanced attribute settings. Here, advanced attribute settings. And this section allows you to define custom radius attributes beyond the standard ones in common tasks. So you can create them in here. So there's a drop down for the radius type. And then there's an operator, and then you can specify a value and so on. So this is really for fine-tune device behavior, and if you wanted to integrate with a specific vendor system and to override any default values. So that's it for this demo. There's more demos to come, but for now we are moving on to ISE deployment. So this is to do with the ISE components, and this slide is on the ISE node types and personas roles. So a bit more around the deployment of Cisco ISE. So the Cisco ISE node is a single instance and installation of the Cisco ISE software that runs on a physical or virtual machine or in the cloud. There are different node roles called personas, which define what the node does. There are three main personas: admin, policy, and monitoring. In standalone mode, all personas, admin, policy, monitoring are enabled on a single node. This is suitable for lab, demo, or small-scale production. But in a distributed deployment, roles can be spread across multiple nodes, which improves scale, performance, and redundancy. Let's go over the different personas, which are Policy Administration Node, which is Central Management Point, which is the control center. It handles licensing and policy configuration and logs. This persona distributes configuration to other nodes in a distributed deployment. It manages configuration and operation and provides access to the GUI and CLI. Policy Server Node. This is the workhorse of Cisco ISE. It's responsible for making real-time policy decisions based on user identity, device posture, and contextual information. The PSN handles radius and TACACS plus authentication and authorization requests, posture assessment compliance checks, profiling data such as DHCP, HTTP, NetFlow, etc., and applying policy rules defined in the Policy Administration Node. It also provides the portal hosting for guest access, bring your own devices onboarding, so the portal for those. Next is Monitoring and Troubleshooting Node. It's the engine for logs and reports. It correlates, collects and displays logs, reports and diagnostics. Then we've got pxGrid node. This enables context sharing with other security systems. This feature allows Cisco ISE to share session-related context information with other systems such as Cisco Secure Firewall. The pxGrid framework facilitates the exchange of policy and configuration data between the nodes, including the sharing of tags, policy objects, with third-party systems for purposes like threat intelligence. And access to the pxGrid service requires an Advantage or Premier license. We will have a look at licenses shortly. Now let's take a look at the deployment types. Standalone, we've already kind of looked at this, but standalone, a single Cisco ISE node runs on all personas. PAN, PSN, and MNT run on the standalone device, and the use case is best for small environments, labs, or testing. Limitations are no redundancy or scalability, so if the node fails, services are lost. So it's only useful for testing purposes, or if you have it in a lab environment or a pre-production environment. Standalone is the default, by the way, and everything is installed on a single server, so no scalability or fault tolerance, and it has a maximum capacity of 2000 endpoints regardless of the size of the server. It's only suitable for lab environments, small networks, or not critical networks. Next is redundant two-node deployment. In small deployment, redundancy can be achieved by adding a second node, known as a two-node deployment. This secondary node serves as a backup for all personas and should match the primary node in capacity. Although overall system capacity doesn't increase, both nodes can share radius and TACACS Plus processing. It helps to balance the load and ensure service continuity. By the way, capacity depends on the hardware and licensing in use, and if the primary node fails, the secondary node can be promoted to take over configuration and monitoring duties, which minimizes downtime. So we can see on the right we have the two node deployment, and both of them have PAN, PSN and MNT personas on each device. So we've got some redundancy there. Moving on to a 4-node deployment. A 4-node deployment is a distributed deployment model that provides better scalability, redundancy and performance than a standalone or a 2-node setup. Here's how it's typically structured. We've got the node roles, the personas. The primary PAN, policy administration node, manages configurations and policies and only one active PAN at a single time. Then there's primary MNT, the monitoring and troubleshooting node. It collects and displays logs, reports and session data. Then we've got PSN1 and PSN2. So PSN1 handles live radius TACACS Plus authentication, authorization and posture checking. And PSN2, the policy server node again, but policy server node 2, load balanced with PSN1 for high availability and increased throughput. So the 4-node deployment is just one of the baseline common examples. It's not a limit. Cisco ISE can scale well beyond 4 nodes depending on how you structure your deployment. So scalability can be enhanced by separating the policy node persona, referred to as the policy service node, into a dedicated node. When a node runs on the policy service persona, its endpoint capacity depends on the underlying hardware platform. We can see on the right we've got the PAN MNT. Then we've got PSN1 and PSN2 being load balanced by an F5 load balancer. And at the bottom we've got theoretical node limits. So we can see the limits. But we can see here policy service node up to 50 in most deployments. Total ISE nodes, it varies, but typically up to 54 nodes. 2 PAN, 2 MNT and 50 PSNs. So it can scale really well. Cisco ISE deployment types continued. The admin persona is commonly known as the policy administration node. In this setup, one node acts as the primary PAN while another serves as the secondary PAN for redundancy. The monitoring persona, also known as the monitoring and troubleshooting node, also has designed primary and secondary roles. And to reduce inter-node communication overhead, it's best practice to host both the primary admin and monitoring personas on the same node, and likewise to place the secondary personas together on another node. Also, scalability is enhanced by separating the policy service persona, referred to as a policy service node, onto a dedicated node. And I may have mentioned this before, but when a node runs on the policy service persona, its endpoint capacity depends on the underlying hardware platform. The policy service persona does not have a concept of primary or secondary roles. Policy service nodes act as radius servers for network access devices in the deployment, where you can configure network access devices to prioritize one PSN over another. The PSNs themselves operate independently and are unaware of the network access device's preference or priority settings. So just bear that in mind. The Cisco admin node. So every Cisco ISE deployment requires at least one admin node for redundancy. A second admin node can be added with one designated as a primary and another as a secondary. Cisco ISE supports automated failover for the admin persona. If the primary admin node, the PAN, fails, the system automatically promotes the secondary to maintain management functions. Although a secondary admin node is optional, deploying one is considered best practice to ensure high availability. Cisco ISE policy server node. While the admin node manages policies and collects endpoint attributes, policy service node is responsible for runtime functions like user and endpoint access. Policy service node handles real-time policy-driven decisions and communicates these policies directly to the network access device or devices for enforcement. If the administration and monitoring personas run together on the same node or paired nodes, the deployment supports up to 6 policy service nodes. And if administration and monitoring run on separate nodes, the deployment can run up to 50 policy service nodes. It basically comes down to resource utilization and system scalability limits, as when the administration and monitoring are on the same node, they use a significant amount of CPU memory and disk utilization, especially monitoring, which deals with large volume of logs and analytics. This limits the system's ability to scale and coordinate a larger number of PSNs. I feel like I've done all this a couple of times, but let's just quickly go over this one. The smallest redundant Cisco ISE deployment, known as a split deployment, includes 2 nodes. One acts as a primary node and handles configuration, authentication, and policy management, while the secondary node serves as a backup to ensure network continuity if the primary fails. In this setup, the AAA workload is shared between both nodes to improve performance. While one node may be designated primary, neither handles the entire load during normal operation. Both must be capable of managing the full workload independent in case of failure. As the network expands, additional ISE nodes can be added to form a medium-sized deployment. These new nodes can take on AAA responsibilities, allowing the original node to focus on configuration and logging. So AAA is authentication, authorization, and accounting. For large-scale deployments, it's recommended to use centralized logging. This involves assigning a dedicated node with monitoring persona to handle high volumes of syslog traffic. Logs can be sent to an external syslog server as a backup, ensuring redundancy. Since Cisco ISE uses RFC 3164 compliant syslog, any compatible syslog server can receive logs. A centralized logging setup enhances reporting and alerting across the entire ISE deployment, so it is recommended. The Cisco ISE monitoring node. The monitoring node handles log collection, event correlation, and reporting. It maintains a session directory that tracks all active sessions in the Cisco ISE deployment. In deployments with multiple monitoring nodes, both active and standby nodes collect logs. If the active node fails, the standby node takes over, and each policy node must forward logs to all monitoring nodes because they do not synchronize with each other. Logs are collected locally for each node and sent to the monitoring nodes, which can then forward data to external log servers for secure long-term storage and forensic analysis. And a collector agent on each Cisco ISE node gathers data and sends it to the monitoring nodes, where a collector process passes and stores the information in the monitoring node database. Policy service nodes sends logs using syslog over UDP port 20514, and in redundant setups, logs are sent to both monitoring nodes. Moving on to Cisco pxGrid. pxGrid is an information sharing platform that enables context data exchange between Cisco ISE and other Cisco products or ecosystem partners. It acts like a messaging bus for sharing policy and configuration data between nodes. Cisco ISE serves as the pxGrid controller, managing client authentication, authorization, and maintaining a directory of available context topics. pxGrid is disabled by default and requires a Plus license. Clients can register with the pxGrid as publishers, subscribers, or both to share or request information. Common integration includes Cisco Secure Firewall and Cisco Secure Web Appliance, which use pxGrid to enforce policies based on user group or context data from ISE. For example, Cisco Secure Firewall can connect to pxGrid to access user and device identity data, enabling policy enforcement based on attributes like Active Directory group membership. An MDM solution, mobile device management solution, might also join to share details about device OS versions, patch status, or antivirus protection. So we can do that as well. And by allowing all connected systems to exchange context, you may see where this is going, but pxGrid enhances visibility and strengthens the ability to detect and respond to and mitigate security threats. Third-party systems can also use this information to quarantine users or devices during security events. Cisco TrustSec scalable group tags, SGTs, and endpoint profiles with fully qualified domain names can be shared across networks via pxGrid, which also supports bulk downloads of this data. In high availability setups, pxGrid information replicates through the primary admin node. If the primary admin node fails, pxGrid stops processing client registration and subscriptions until the primary admin node is manually promoted. And all administration and policy service nodes share a common database. When policies are updated, changes sync to all nodes, ensuring the secondary admin node can take over if needed, and policy service node have current policies for making real-time decisions. I am back on the ISE dashboard. I want to show you the ISE nodes. I think we had a look at this, but let's have another look. So we go to administration and deployment, and we can see there are 4 nodes, and we can see what personas they are running. So the top 2, they are running administration, monitoring and pxGrid. Then we can see 2 dedicated policy service nodes over here. We can click on one of these and then click edit. And in here we can see its details: host name, fully qualified domain name, IP address, the node type, ISE role, it's a primary node. I guess the other one will be a secondary node. So if I click on edit on that one, that's a secondary node. And we can see what's turned on the actual node itself. Notice it's got the monitoring persona turned on, which is acting as a secondary monitoring persona. It's not a PSN, policy service node, but it has pxGrid turned on. So this node enables information sharing between the network devices in real time and on demand. Let's go and have a look at one of the other nodes. Let's have a look at the policy service node. So on here we can see it's not got the admin or the monitoring persona turned on, but we do see the policy service persona turned on. If we notice, this also acts as a TACACS server because it's got this device admin service turned on. So administrators can log in to network devices via this service. So it will enforce access control as device admins log into network devices. And it has profiling services turned on as well. So it will profile devices. It will work out what a device is, whether it's a Windows device, an Android phone, etc. It could be a printer, a camera. So this is done via this profiling service. And we can see there's no Threat-Centric NAC service turned on this node. So Threat-Centric NAC is there to consume threat and vulnerability information from endpoints from third-party vendors and take actions by allowing the ISE admin to create authorization policies around threat attributes. So it's a little bit more of an advanced feature. New features in version 3. So we are having a look at version 3, which is the latest major version. We have agentless posture assessment. It adds posture checks without needing an installed agent. Complementing agent-based methods is critical for zero trust device security. Then we've got a revamped API gateway, which centralizes REST APIs for improved security and automation. Next is infrastructure automation, which is built-in support for Ansible and Terraform for ISE-based deployment and configuration. Next, moving to ISE 3.1, 3.2, we have fewer but notable features, mainly licensing updates and platform maturity. And moving on to ISE 3.3, it supports split upgrade, so you can upgrade specific ISE nodes in parallel to minimize downtime. It supports control app restart, postponing component restarts, for example certificate renewals, without full node reboot, artificial intelligence, machine learning profiling and multi-factor classification. It identifies unknown devices via cloud-based machine learning into categories, for example by model or operating system. Wi-Fi Edge Analytics, it leverages Catalyst 9800 controllers to enrich profiling data from Apple, Samsung, etc. IP version 6 everywhere. It extends IP version 6 to support Radius, TACACS Plus, Posture and guest portals. And there are some security enhancements, for example TPM support on SNS 3700 VTPM hardware. I'm not sure what that is, to be honest. TLS 1.3 support for UI API access and admin control over Cypher suites. And looking at 3.4, which is the latest version, we've got common policy, which is in beta actually. So unified zero trust policy engine to orchestrate access across devices, users, apps and Cisco ISE fabric. Active Directory preferred DCs, so admins can set priority for DCs. Supporting automatic failback and failback on outages. Faster reboot times. Nodes restart now measured in minutes, not tens of minutes. So effectively it's faster. Then we've got the pxGrid direct enhancements. I'm not going to bother reading all of these. you can see them, but we've got sync now for immediate CMDB updates. We've got persistent UI preferences, localized ISO install, patchless TrustSec, fully qualified domain names to SGT mappings, log file management, Lua scripting, TLS 1.3 and patchless radius, pxGrid filtering, and dynamic re-authentication. So these are all pxGrid enhancements. And finally, these are the latest capabilities of ISE 3.5. So for security and compliance, with most organizations, they're concerned about encryption and secure administration. TLS 1.3 removes outdated ciphers and speeds up secure connections. And FIPS 140-3 is important for banking or high security environments. It shows ISE aligns with the latest US crypto module standards, which are up from 140-2. So for security, ISE now supports TLS 1.3 everywhere, including TACACS Plus, and meets the newest FIPS 140-3 crypto standard. For profiling and authorization, the cloud classifier gives ISE more intelligence for Internet of Things and bring your own devices. And modern enterprises use Azure AD. This makes authorization dynamic. So if a user moves OU, changes group, fails a condition, ISE can change access automatically. So the cloud classifier greatly improves device identification, and Entra ID attributes now triggers live changes to access, which fits zero trust. With integrations, pxGrid Cloud makes third-party onboarding much easier, and using Cisco Duo, integration is stronger using certificates. And finally, for management and operations, new licensing, audit reports, and smart alarms makes ISE easier to manage day to day. Now let's look at licensing model, in particular for 3.x. In addition to licenses for network access control, separate licenses are required for device administration and for deploying Cisco ISE on virtual machines. Now let's look at the 90-day license. Upon installation, Cisco ISE provides a 90-day license that supports up to 100 endpoints and includes full feature access. This allows you to deploy a limited setup and explore the complete capabilities of Cisco ISE. ISE subscription licenses, starting with 3.0, all licenses are subscription based, available in 1, 3 or 5 year terms. The licensing model is tiered and stacked: Essential, Advantage and Premier. You only need to purchase the highest tier required, as it will include the features of the lower tiers. For example, a Premier license includes both Advantage and Essential features. You can manage licensing via Smart Licensing with a Cisco Smart account. And having a brief look at Cisco ISE 3.1 for virtual machine licensing. Cisco ISE 3.1 introduces a cloud-friendly virtual machine licensing model with a simplified common VM license, replacing the older small, medium, large tiers. This model supports flexible deployments, including in AWS, that's Amazon Web Services, and allows admin and monitoring nodes to run on different ISE instance types. Now that we have had a look at ISE components, personas and nodes, and licensing, let's move on to policy sets. We did have a brief look in a demo on authorization profiles, which is part of policy sets and part of the ISE policy management. So we will have a look at where that comes into play, as well as the bigger picture when managing ISE policies. Policy set is a container for access control rules in Cisco ISE. It defines how ISE evaluates, authenticates and authorizes decisions for a given network access request. Think of it as a rule book. It groups together authentication, who, what is trying to connect, and authorization, what level of access do they get. And each policy can be tailored for different network access methods, user groups or scenarios. So key characteristics of policy set is top-down evaluation. ISE checks policy sets in order the first match is applied. It's context specific. For example, different policy sets for VPN users, a different one for wireless, bring your own devices or wired corporate devices. It simplifies administration. Instead of one giant rule table, you create smaller scenario-specific rule sets. It includes conditions, so user identity, device profile, posture status, security group tags, and time location. So if we look at an example flow, request hits ISE. ISE selects the right policy set, for example, wireless access. Then there's the authentication policy, which is checked. So it does an EAP, TLS certs, AD credentials, or MAB fallback. Authorization policy is applied, so full access if compliant, or quarantine the VLAN if it's not compliant. From a policy management perspective, this slide might be easy to understand. So when we have a look at every connection entering the network, it is first matched against a policy set. So this determines which policies are evaluated. So it acts like a traffic director, it directs traffic. And then from there, the authentication policy confirms who or what the endpoint is. So it verifies identity of the user or the device. Next is the authorization policy, which determines which access privileges are allowed. And the next two are profiling and posture, which can modify the outcome by providing deeper context about the device's type and security state. So profiling adds device context, for example, a printer, a laptop, a camera. And actually I have a demo of profiling. So we are going to have a look at device profiling shortly. And with posture, it checks security compliance before and after access. So to ensure the device has antivirus and it's up to a certain patch level and so on. And finally, at the very bottom, we can see the enforcement results. So these are where ISE enforces the decision using either VLANs or downloadable access control lists, or ACLs, access control lists, and URL redirects. So these are the actions we take. Rather than talking about policy sets on the slides, I'd rather show you on the ISE dashboard. So we are on the ISE dashboard, and I wanted to show you the policies, a quick look at the policies. So if I go to policy and then I go to policy sets, these are where all the policy sets are. So if I go to one of them, let's go to corporate posture. Here's the conditions, it's showing me the conditions here, the description, the policy set name, corporate posture. Posture policy for San Jose employees. These are the conditions to match the policy set, and these are some allowed protocol service sequences, hits, actions. We can do actions from here as well, some actions, or we can just go into the full policy set from here. You can actually create policy sets from the top left here by hitting the plus icon. That's the new policy set. Just going to reset that so it removes it, and then we go back into corporate posture. Now we are in the policy set, and above right at the top, this is the policy set condition, or it's also called a policy set matching rule. So Cisco ISE processes policy sets in 3 layers. Layer 1 is the policy set matching rule, and then layer 2 is the authentication policy, and then we have layer 3 as the authorization policy. So see this as the first condition in ISE. So ISE looks at every incoming radius request and tries to match it against the policy set using this rule. So this rule decides, if we have a look at the conditions of this rule, it's saying the device location must equal, and then we see SJ1 for San Jose. So only if it matches the device location equals SJ1 and it's a wireless 802.1x request, or you can see or here, or a wired 802.1x request, then ISE will enter this policy set and then continue to the authentication policy and authorization policies inside it, and optionally MFA policy. So at this stage it's not doing any authentication and authorization, it's just the conditions to match this policy set. By the way, when I mentioned device location, well, ISE uses the network device groups to tag devices by location. So this condition filters traffic based on where the switch or the wireless LAN controller is physically placed. So this allows you to make location-based policy sets. So London or San Jose can have specific authorization actions without affecting any other site. And it also groups both wired and wireless 802.1x into the same rule, making the policy simple and scalable. Next, we have the authentication policy. So this is about what identity source to use. You can see the identity source on the right hand side, use. In here it's using AD sudo co. That must be an Active Directory server. You can also specify what EAP methods are allowed, what conditions match, for example 802.1x or here wired 802.1x. Should I say wireless 802.1x or wired 802.1x? And again which AD store or certificate rule to reference, so you can do that over here. And you've got some further options in here. If authentication fails, reject, drop, continue. So, for example, let's say the user is in San Jose, the device is in San Jose, and it's a wired or a wireless 802.1x request. So it passes both of these conditions, passes the policy set condition and the authentication policy condition. So therefore it moves to authorization policy. And the authorization policy is after the user or the machine is authenticated, ISE applies the authorization rules. So that's whether you apply specific VLAN, security group tag, an ACL, downloadable, ACL, posture requirements, network access, and so on. And we can see these down here. Actually, just before I go to those, these are the conditions. So you can click on the conditions as well. And here's a condition studio. You've got some conditions here. You build your conditions in here, so you can search for them. The condition studio in Cisco ISE is the GUI used to build compound conditions for policy set matching rules like the one we are editing. Authentication policy conditions, authorization policy condition, authorization rules, profiling conditions, or device conditions. Those are network device groups. It's essentially a visual condition builder that lets you stack and or nested logic pre-built condition objects. And then these small icons across here, for example, address, certificate, framed, identity group, location, network device, OS, password, port, protocol, server, session, subject, time, unclassified, and Wi-Fi. These represent categories of the conditions, and inside each category you only see conditions if your environment has them configured or if ISE has auto generated them. So some of these I'm not going to see. So these are not populated because ISE does not auto populate most libraries unless we've added profiling policies or added custom conditions or certificate templates, endpoint attributes, and so on, or network device groups, or we have imported AD and attributes. But these wireless 802.1x or wired 802.1x, these are system defined conditions, so these will always appear. But as we're working in a simulated environment, it's got minimal data or no data. Most of these categories have no data, so that's why these icons appear empty. Anyway, this is Condition Studio. This is where you build your conditions. And then we have authorization policy. If I hover down, we can see the authorization policies. So for example, if the employees are compliant, so that's a rule name, employees compliant. The conditions will be, this is part of the group _ employees and compliant devices. So the device will be compliant. And the result will be, it will get the profile employee access. It will also get security group tagged. Security groups, employees, but let's focus on the employees access. So what is this actually doing? Employees access. So this is where we want to go back to policy and under policy elements. Policy elements, by the way, is what makes a policy set. It's all the components of a policy set. If we go to results, we want authorization profile. So if we break that down, authorization profile, and the one we are looking for is employee access, to this one down here. So let's have a look at it. Let's see what it's actually going to do. And for this one, it's got a dynamic access list applied, which is permit all IPv4 traffic. And then we might ask, well, what's this doing? This is actually a built-in system downloadable access control list, but it does say down here access except permit all IPv4 traffic. Basically, this is a permit IP any. And if we go to downloadable access control lists, let's say you had created one yourself. This is where you can see it to see what it's doing. So it was this one here, but we are not permitted to open it because it's a built-in system one. It's just a permit IP any. But if we open, let's say this one, guest ACL, we should be able to see the specific ACLs inside it. So we can see them inside it, what it's permitting and what it's denying. If we go back, there's another example, contractor downloadable access control list. So you can see here it's denying access to this IP address and it's permitting everything else. So that's how you tie it all up. So if we go back to authorization profiles, the authorization profile will tell us what it's doing. Employee access, and for this particular one it's permitting all IPv4 traffic, and you can see the content of this in downloadable access control lists. Obviously this is a system built-in one, so we cannot see this, but it's a permit IP any, and then you tie the authorization profile, this one, employee underscore access. Well, there's many of them. There's also another one here, guest access, for example. This will be doing something else maybe. It's got another downloadable access control list tied to it, guest access. And then you tie this to the policy set, or should I say the authorization policy within the policy set. So over here. And that's pretty much it from a high level. Policy sets, policy set conditions, authentication policies, authorization policies, and the authorization profiles. That's the demo done on policy sets. Now let's go back to the presentation slides before we look at another demo on device profiling. So let's look at Cisco ISE in the cloud. Cisco ISE is available as an infrastructure as code solution. It enables fast deployment of network access control and services anywhere. In AWS, you can deploy ISE using CloudFormation templates or Amazon Machine Images, with Cisco recommending CloudFormation templates. CloudFormation templates simplify cloud deployment by automating the creation of resources like VPCs and virtual private gateways, allowing secure communication with your on-premise network over an IPsec tunnel. Cisco ISE Guest Management Overview. So Cisco ISE provides a comprehensive solution for managing the entire guest access lifecycle from onboarding to secure session termination. It basically enables organizations to provide temporary and secure network access to guests, contractors and visitors while maintaining full control and visibility on their access. Guest access methods in Cisco ISE. Cisco ISE supports 3 primary guest access use cases. Hotspot access. Hotspot access provides quick and open internet connectivity without requiring user to authenticate. This is ideal for public or low risk environments such as lobbies, cafes or waiting areas where ease of access is prioritized over identification verification. And then there's self-registered guest access. In this model, guests or contractors create their own accounts through a self-registered portal. And depending on your configuration, these accounts can be auto-approved or require sponsor approval. And self-registration simplifies guest onboarding and can be tailored to grant different levels of access, such as internet only or limited internal access to resources. The last one is sponsored guest access. Sponsored guest access is a more controlled approach where an internal employee, which is a sponsor, is required to create or approve a guest account before network access is granted to that guest. This ensures guest access is tied to a responsible party and enables role-based access control. It's suitable for environments with tighter security requirements or regularity policies when you have to follow regulations. Most Cisco documentation, training material and diagrams simplify guest access into the 3 main models. That's hotspot, self-registered guest and sponsored guest. There's also another model as well. Sometimes they do 4 main models. However, this is a high level abstraction and there are actually variations of these depending on your specific requirements. And here are all of the variations. So what do we see? We see the key differences explained. This is a quick guide so we can see for hotspot has 0 friction, is no identity tracking, lowest security and users acceptable use policy, AUP. So 0 friction means there's hardly any work to do with it because the user only has to accept the AUP and then they get access to what is usually access to the internet. And if we find hotspot, here we are. So there's no login required. Who creates the account? Nobody. There's no actual account. Approval needed. There's no approval needed. Access level, internet only. Typical duration, so it's short, minutes to hours. Portal type, it's a hotspot portal. And the best use case is for cafes, lobbies, public waiting areas. So the rest follow on. So we've got self-registered guest, sponsored guests, fully sponsored regulated access and SMS social logins. But you can see exactly all of the model comparisons down this row and their best use cases. And then you can see what features they're using, turning on and off. For example, let's go through another one. So sponsored guest access over here, employee created. So a login is required. The sponsor, the employee, creates the account. Approval needed, yes. So we do need approval. Access level, yes. So internet plus limited access. or limited internal access. So it could be a guest who needs some temporary services within the network. So you give them access to those specific services. And then how long do they need it for? Typical duration, days to weeks. And the portal type, sponsored guest portal. And finally, what's the use case or the best use case if it's a contractor or a vendor? So we may have contractors, and contractors usually need access to whatever they're working on. So back again up to here, so back to access levels, you'd give the contractor access to whatever they're working on. So if it's a contractor for the HR department, you give them access to HR services, or it could be a contractor who works in marketing, you give them access to marketing services and so on. So that's a high level of guest access model comparison. And you can see all the differences within this table here. And on the left, there's a bit of guidance, what makes them unique from one another. Customizable guest portals. Cisco ISE allows administrators to customize guest portals to align with organizational branding and policies. So this can be custom login pages, usage policies, language localization, terms of use acceptance, SMS, which is mobile phone messages or email verification, and time-based access expiration. Each of the portal types, hotspot, self-registered and sponsored, can be tailored to meet different business needs. We are back on the ISE web GUI and I wanted to show you guest access. So the guest access, just as a reminder, it lets you provide secure network access for guests, such as visitors, contractors, consultants, and customers coming into your network. ISE offers 3 types of guest portals: hotspot, self-registered, and sponsored. Hotspot is a simple acceptance of terms and conditions to connect, where self-registered requires creating credentials and sponsored involves someone else creating credentials for the guest. Now on the web GUI, if I go to policy and policy sets, then we can scroll down to this one here, MAC-based authentication. You can see in the description it says policy for hotspot, guest and Internet of Things. So this policy is used when MAB, which is MAC authentication bypass, authentication is used, which is the case for guest users connecting to an open SSID or to a switch port that is configured for MAB. So if we go into the policy, and now if we expand the authorization policy to see the rules, now the bottom few here we can see hotspot access, hotspot redirect, guest access and guest redirect. So when a user tries to connect to a guest, they are first redirected to a guest portal. There can be more than one guest portals for different types of guest access. In our configuration, the type of guest access and its corresponding portal depends on the SSID the user is connected to and associated with. For us, we have 2 SSIDs in our network considered in the rule conditions. So we can see the rule conditions over here. And the 2 are hotspot and guest. So SSID underscore hotspot and SSID underscore guest. And once the guest flow is completed by either accepting the acceptable user terms and or entering their guest credentials, the user is allowed the corresponding guest access. So if we take a look at this one, hotspot redirect, we can see in the profiles the result. The result is hotspot redirect. So this is the profile, and we can take a look at this profile. If we go to policy and results, and then we go to authorization profiles, we can search for hotspot redirect, which is this one here. If we go into it, and if we hover down where we see common tasks, now in here, if we notice the common tasks section, we see there is a web redirection rule. So this is how ISE tells the network that a user needs to be redirected to a specific guest portal. And in our case, the portal name is sudo guest or sudo co-guest. So if we wanted to see this portal, how it's configured, how you create the portal, we go to work centers, and I've already got guest broken down here. If we go to portal and components, we can see the different portals. So you can create new portals from here or edit them, duplicate them, delete them. And we can see this one in the middle, sudo co-guest. We can also see it says used one rule. So if we click this one, we can see it's the rule we just had a look at, the rule hotspot redirect. In policy set, MAC based authentication. So this is how it all ties together from the policy set, the authorization policy, and then the authorization profile, which references the portal. And then this is where you create the portal itself. Maybe we can see one more. If we go back to policy sets, and then MAB, and then this rule here, MAC based authentication. Again, drop this down, authorization policy. And there's one here at the bottom, guest redirect. So we can see the guest redirect profile. So if we go to policy and then results, we can see in authorization profiles, the guest redirect, which will be here somewhere. And we see it over here. So if we click guest redirect, we can see in common tasks, the web redirection for guest redirect, and it's a self-registered guest portal. Now if we go to Work Centers, Portal and Components, we can see the portal itself. We can see it's been used in 2 rules. But I wanted to show you how to edit the portal or what's inside the portal. Yeah, for some reason that's not working. It is Cisco D Cloud, maybe they've restricted it for some reason. So unfortunately I'm not able to show you the portal itself, inside the portal, how you configure the portal. But we do have things like the portal behavior and flow settings, the portal page for customization, so you can customize the page like the title and the footer and the theme and the color of the portal, and upload your own corporate image, things like that. We've got the portal settings, the login page settings, the registration form settings, and then you also have a workflow. It shows you what the guest will go through as per the workflow. For example, the guest needs to log in, and then it has to accept an acceptable user policy. And next, the user may be required to change the password because he has not changed the password for a while before the user logs in. Or in this case, it says maximum devices reached in case he's logged in from too many devices. So of course, this workflow is based on all of your settings, what you configure. BYOD allows employees and in some cases contractors to use their own personal devices to access corporate resources securely. Cisco ISE provides a self-service BYOD portal where users register their devices themselves, reducing IT operational overhead. During onboarding, ISE can install certificates and apply security checks, ensuring only trusted and compliant devices are allowed onto the network. Unlike guest access, BYOD devices are typically granted longer-term access and may reach internal resources, but only after meeting defined security requirements. And finally, BYOD is particularly useful in modern, flexible workplaces where mobility, remote work, and multiple device types are in the norm. So everyone has these kind of device types, which is pretty much every place in today's world. Everyone has mobile devices. By the way, guest access and bring your own device in Cisco ISE are related, but they are not the same feature. They solve different problems and use different workflows, and they rely on different ISE components. So guest access provides temporary limited network access, is for visitors, contractors, customers and partners, where bring your own devices, BYOD, is for onboarding employee-owned devices securely. So it's for staff using personal laptops, phones and tablets. So guest access equals temporary network access, where bring your own devices equals device onboarding plus establishing trust with those devices using certificates. So guest access provides limited access, internet only for example. It doesn't need certificate, no endpoint onboarding, and the sessions typically are short-lived. And the identity stored is inside an ISE guest user database, which is temporary. With bring your own devices, it uses BYOD portal. It performs device onboarding, which includes device registration, profile installation, and certificate provisioning. It installs an X.509 certificate on the device. It allows EAP TLS or TEAP TLS for secure authentication, and the device becomes a known trusted asset. Let's move on to device profiling, and we will have a look at a demo of this as well. Device profiling in Cisco ISE is the process of automatically identifying the type of device connecting to the network. For example, it could be a laptop, a smartphone, a printer, IP phone, or Internet of Thing device. It could be a camera, for example. And this is based on its network behavior. So ISE uses information such as DHCP, HTTP, radius, MAC, OUI, and traffic patterns to build a device profile, which is then used in authorization profiles to grant the appropriate level of network access without manual configuration. We can see in the range on the right some of the ways it identifies devices. So we have in this example MAC, OUI, DHCP, HTTP. Of course there's others as well like DHCP and radius. And then it goes through profiling policies if specific attributes are detected. For example, DHCP, MAC, OUI, HTTP user agent. Then ISE assigns a device profile such as a Windows PC, iPhone, printer, IP phone, or another Internet of Things device. And these policies run continuously and can upgrade or refine a device's profile over time as more data is learned. The resulting profile is then used in authorization policies to decide what level of access the device should receive. It uses a certainty factor, and if that value is met, it is confident that the device is classified correctly and classifies the device, which will make more sense in the demo. So we will have a look at all of this, including the certainty factor in the demo. So the purpose is to collect device information to enable policy enforcement by automatically analyzing network traffic patterns and identifying device types and operating systems, and these are the benefits. It replaces manual device identification. It enables smarter role-based policies, and for example, it restricts smartphones from sensitive resources, for example, financial applications or data. Let's take a look at a demo of device profiling. We are back on the dashboard, and I wanted to show you some stuff on profiling. So again, if we go to administration deployment, we've seen where the node has profiling turned on. If we go into the node, one of the nodes, the policy service node, and we can see here enable profiling service. With profiling services, it dynamically detects and classifies network connected endpoints using attributes such as MAC addresses, CDP, LLDP, DHCP, and others as well. So ISE collects information about these endpoints using these probes, and it uses pre-built user-defined or AI profiling policies to define the endpoint profile. ISE also offers the ability to create logical profiles to create groups of similar devices such as workstations or smartphones. So a group of workstations or a group of smartphones, etc. Once classified, so once the endpoint is classified, the endpoints are authorized and granted network access based on their profiles, allowing for differentiated access depending on the device used. So profiling is critical in the IoT or OT space because devices are not capable of performing 802.1x and rely on MAC address bypass to get network access. So ISE collects device attributes via probes which allow the proper classification of the device. Probes are configured per node in ISE. So let's have a look at these. If we go to administration deployment, which we are already in actually, if we scroll back to the top, and we have this profiling configuration tab. So in here we can see the probes and the probes that are turned on. So we can see DHCP is turned on. We can also see radius, network scan, Nmap, and SNMP query near the bottom as well. Active Directory as well. So depending on your environment, you may require to turn on additional probes. Typically, the radius probe is one of the most powerful when combined with the device sensor. The device sensor is a feature on Cisco switches and wireless LAN controllers that inserts CDP, LLDP, HTTP, and MDM information inside the radius accounting packet, therefore minimizing the need to turn on additional probes on the ISE node. If we have a look at profiling policies, so profiling policies dictate what conditions need to be met for a device to be classified into an endpoint profile. The conditions are based on the attributes gathered by the profiling probes. And logical profiles are a way to group similar endpoint profiles into a single category. For example, the logical profile cameras can contain all of the different cameras or the camera vendors in your network if you need to create a unified access policy for all your IP cameras in your network. So if we go to Workstation and then we go to Profiler, if we click on here, we'd see more options in here. So you can see more options in either of these: network access, posture, device administration, passive ID, bring your own devices, TrustSec, guest access. But what we are looking at is profiler policies. Some of these policies are pre-loaded in ISE and maintained by Cisco themselves, and periodic updates of the profiling policies are performed via profiling feeds downloaded from Cisco. But we can also create our own customized profiling policies as well. We can expand this over here, profiling policies, and we can click on any of these. Let's click on maybe Apple device or Android device. We can see here it says no data available. So I'm not sure if this is working because it's a simulated environment. Let's click on the top one. I'm sure this one works. 2-wire device. So at least we can see this one. Okay, none of the others seem to work. 2-wire device does. So that's good enough for us. So just a reminder, profiling automatically identifies what kind of device is connecting to your network. For example, a printer, a VoIP phone, a laptop or a mobile phone. I'm not sure what 2-wire device is in this particular example. ISE does this by collecting attributes again, like MAC OUI or DHCP fingerprinting, HTTP user agent, SNMP, radius info, etc. And it collects it from multiple sources, then matching them to profiling policies. This profiler policy page is where you define how ISE decides what device belongs to a particular category and what to do when it matches. So essentially it's a rule-based engine that assigns devices to identity groups based on certain factors. Each profiling policy, like an Apple device or a 2-wire device in this example, has its own rules and confidence levels. So we have the name of the profiling policy, 2-wire device. The policy is enabled, so we can check that or uncheck that. If we want to disable it, we uncheck it. Minimum certainty factor. So this defines the confidence level threshold required to classify a device as this type. So each profiling rule, which is a condition, adds a certain certainty factor score. When the sum reaches or exceeds this number, it's 5 in our example. So when it reaches or exceeds this number, ISE decides this is a 2-wire device. So it will be confident it's a 2-wire device, and it will decide it is, in fact, a 2-wire device. So for example, if a rule adds +3 and another adds +2 certainty points, then the total will equal 5 and it will meet this threshold. So the device is then classified as a 2-wire device. Exception action. This defines what ISE should do if something unexpected happens during profiling. Typically, this is left as none unless custom exception handling is configured. Nmap, network scan. It lets ISE trigger an Nmap scan on the endpoint to gather additional profiling data, like OpenPort's OOS info. None is for no scan. Default uses the default Nmap scan template, or custom if you've defined a custom scan policy. Create an identity group for the policy. This determines whether ISE automatically creates a corresponding identity group for device that matches this profile. If yes, it creates matching identity group. ISE makes a group named after the policy, and if no, it will use existing identity group hierarchy, so devices are placed into an already defined group. Identity groups are used in authorization policies. For example, if the device is in an Apple device group, then assign it a VLAN of 30. That could be an authorization policy. Parent policy, so it allows hierarchical profiling. A parent policy can hold child policies. For example, Apple device could be the parent and an iPhone or MacBook can be child policies. Associated core type. This defines how ISE notifies the network device when a device's profiling status changes. So in here we've got global settings, uses the system-wide core configuration. This uses the system-wide change of authorization configuration. So core is change of authorization. Or custom you can define a specific core behavior for this policy, and COA can trigger actions like re-authentication or VLAN change once profiling completes. System type, Cisco provided, so this indicates if the policy is Cisco provided or custom. Cisco provided policies come preloaded with ISE for common device types and are regularly updated via the feed service. And probably the most important part is the rules. So this defines how ISE identifies the device. So this is the logic behind profiling. So if condition that must be met, for example, a MAC OUI matches 001122 or something, a MAC address, or a DHCP fingerprint contains 2 wire, then this defines what happens. In here it's certainty factor increases. When the condition is met, increase certainty factor. So it could be something like if DHCP option 60 equals 2 wire, then certainty factor increases by 5. So that would be a rule. And when the cumulative certainty score is greater than the minimum certainty factor, ISE classifies the device as 2 wire. So this is how profiling works. This is how ISE classifies, or you can say profiles, devices. By the way, when a device is connected to the network, ISE starts to gather this information from the probes, allowing the rules to be evaluated. And every time a condition is met, then the certainty factor increases by the value configured in that rule. For the overall policy to be selected, the certainty factor should be greater than the minimum certainty factor configured in the first section. So the minimum one is 5 over here. And if more than one profiling policies met the minimum certainty factor, then the one with the highest certainty factor value is selected as the endpoint profile for that device. If more than one profiling policies met the minimum certainty factor, so we had more of these policies with this certainty factor, then the one with the highest certainty factor value is selected as the endpoint profile for that device. So this is not a brilliant example, it's only got the one rule. Nothing else seems to work, so we'll stick with that one. And here's the logical profiles. We can select one of these. Let's select cameras. We can see we've got cameras, gaming devices, home network devices, IP phones, infrastructure network devices, medical devices, mobile devices, printers. Let's select cameras. So logical profiles group similar endpoint profiles into more manageable categories, like the categories we just seen, that can be used to create network access policies. And in this case, the cameras logical profile aggregates different types of cameras. And at the bottom of the screen, what we can see is specific endpoints that have been classified or profiled and assigned to the camera logical profile. So we see these two Cisco Meraki devices with their MAC addresses and their IP addresses here. And further, if we go to policy sets, discard changes. And if we expand the MAC address authentication policy set with the arrow to the right of the policy, this policy set matches when the authentication method is MAB and is for either for wired or wireless connections. And if I expand authentication policy, we can see that ISE will use the internal database to authenticate the endpoint. If the MAC address is not found, ISE is instructed to continue with the authorization process instead of rejecting the endpoint. This is the typical configuration for MAB, allowing profiling in ISE to trigger the proper authorization network access. We can also expand the authorization policy. We can see there's 8 in here. We can see the first 3 are printers, IoT cameras, and Cisco access points. There's also hotspot access, hotspot redirect, and guest access. And what we can see is the conditions here. So we can see the conditions for the first 2. Make sure that printers and Internet of Things cameras are connected only via a wired port and matches the corresponding logical profiles. In addition, we are using an attribute coming from an external database, CMDB, to improve the profiling accuracy. The rule for Cisco access points relies only on the profiling policy by calling endpoint policy. And notice the result of each policy assigns a corresponding authorization profile and security group tag value to the endpoint. Now if we go to policy elements results, and then we can go to authorization profiles, we can see all of the authorization profiles Let's click on printers or printer access. So these are our standard authorization profiles. We've already had a look at authorization profiles. Just to go into it, just to remind you what it looks like. But if we go to, if we go to context visibility endpoints, and I want the classification tab. If we go to endpoint classification, and the table entries show the classification details of each endpoint ISE knows. So we can click on the first MAC address, for example, for Grace Smith. That belongs to Grace Smith. And this will open up more details about the endpoint itself. So we can see the endpoint type, a workstation, hardware manufacturer, VMware. The operating system, Windows 11, Enterprise 64-bit. We can also see the applications installed on the endpoint as well. Cisco Secure Client, Cisco Meraki Endpoint Agent, Microsoft OneDrive, DirectX, YouTube, VMware Tools, BitLocker, WordPad. So you can see everything that this endpoint has installed in terms of the application. And of course there's other informational tabs as well, attributes, authentication. And if these were turned on, it would tell you about the threats and the vulnerabilities. So that's quite a lot of information about a particular endpoint you can gather from Cisco ISE. We can also go back to context visibility endpoints. Endpoint classification again. And on the right we can see the AI proposal dashlet above the table. Might need to zoom out a little bit on the browser to see the dashlet. So it says there are profiling policies suggested by Cisco AI Cloud to help profile unknown endpoints on your network. I've not used this, but we can have a look at it anyway. If I click on review. AI proposals are a set of features that group together endpoints with common attributes. It will propose classification rules and suggest relevant labels. So we can see one down here by the manufacturer, hardware manufacturer, Plantronics, Polycom device. We can view the proposal. We can see the attributes used in this rule. So if we scroll down, we can see the details, all the details of the profiling policy proposed by the AI engine. And this proposal is suggesting that 100 unknown endpoints are Polycom devices manufactured by Plantronics. It presents what attributes coming from the probes are used to make that decision. In this example, it's DHCP attributes and MAC OUI that are used to define the AI generated profiling policy. So ISE admins can accept or reject this policy, which provides feedback to the AI engine to improve its accuracy. So if the policy is accepted, it will be added in ISE in a dedicated menu in the profiler section. So if we go to Work Center again, profiler policies, and if we focus on the left menu AI profiles, this is the place where the AI profiles are placed once the ISE admin has accepted the AI proposal. At the minute we've got none. Login, monitoring and troubleshooting, which is a big part of Cisco ISE. It provides visibility into authentication, authorization, posture and network access activity, helping administrators detect issues, verify policies and ensure compliance. So monitoring and logging tools in Cisco ISE are in operations, reports and live logs. You can see real-time view of authentication authorization attempts. You can filter by user device time or policy sets. The profiler log tracks how ISE classifies endpoints, printers versus laptops versus Internet of Things devices. Then we've got Radius live logs, which shows Radius transactions, success, failure, reasons, for example. Troubleshooting tools, we've got TCP dump, Wireshark, packet captures for network level debugging. For example, you can troubleshoot EAP, Radius or TLS handshakes. Then there's system diagnostics, built-in health and posture checks. Context visibility, this is dashboard showing connected devices, users and security posture. And then there's external integrations, which is sys log servers. Forward all logs to centralized log collectors. Splunk and Logstash for SIEM, Advanced Analytics, Dashboards and Alerts, and pxGrid, which shares context with other security tools like firewalls and NAC, for example. Endpoint compliance in Cisco ISE. Cisco ISE can assess endpoint compliance as part of network access control. With the appropriate licensing, it can perform compliance checks on Windows and Mac devices before granting full network access. For mobile devices like iPhones and Android, Cisco ISE integrates with mobile device management solutions such as VMware, AirWatch, Mobile Iron and others to enforce security policies. Determining if endpoints have up-to-date operating system, software patches or antivirus can usually be difficult without MDM solutions. Cisco ISE's posture service automatically assesses these factors as devices connect to the network, and non-compliant devices can be prompted for remediation to improve security. Integration with third-party mobile device management solutions further enhances visibility and control. So Cisco Posture and Mobile Device Management validates endpoints against corporate policies and has capability to integrate with third-party MDM providers. Posture compliance in Cisco ISE. So posture compliance is part of ISE posture services. It's sometimes called posture assessment or posture validation. Initial network access can be limited until the device is evaluated. ISE marks device as compliant or non-compliant based on policy checks. Change of authorization allows dynamic adjustment of access after initial authentication, and profile and posture information can feed into fine-grained authorization policies, and integrating with mobile device management solutions improves the endpoint compliance enforcement and visibility further. Device administration with TACACS. So again, TACACS Plus separates authentication, authorization and accounting for fine-grained control. So administrators can create role-based access policies for engineers, operators or contractors. Every command executed on the device can be logged for audit and compliance. Integration with ISE allows consistent policy enforcement and centralized management for routers, switches, firewalls and other network devices. And it supports both CLI and GUI access control. Threat-Centric NAC Explained. TNAC is an advanced ISE feature for organizations needing threat-aware network access. Its integrated adapters feed vulnerability and threat intelligence into ISE. Based on this data, ISE can limit access, quarantine or restrict privileges in real time. It helps enforce risk-based policies, reducing the likelihood of attacks spreading across the network. One of the most common posture assessments on a user device is to check whether the antivirus is present and enabled and the definitions are up to date. So let's have a look at this configuration on the ISE Web GUI. So the first thing we will do is go to Work Center and we will break down posture. Inside posture, if we look for policy elements. Now if we go to policy elements, on the left hand side we can see conditions. And we are on anti-malware condition, so we can see all of them in here. We can also see the anti-spyware conditions inside here. So if we click on one of these, this looks to say if any anti-spyware Windows installation, so if anti-spyware is installed. So this condition checks if anti-spyware is installed on the system. Likewise, this will check if anti-malware is installed on the system. So what we can do is expand remediations on the left hand side, which is this one over here, and select anti-malware. Now we see two remediation options. If we click on the second one, now this configuration will attempt to remediate an anti-malware failed condition. If we select the requirements option on the left menu, the requirements map conditions with the remediation to be taken if the condition fails. So if we locate one of these requirements, maybe this one, any AV, antivirus installation windows, that would be any anti-spyware installation windows. So this requirement specifies that if any anti-malware, anti-spyware or antivirus, in this case anti-spyware fails, if we hover over to the right hand side, so if this condition is met, a message will be displayed to the user. Message text only, but no remediations for these ones will be actually attempted. Now if we go to posture policy, we can see it on the top as well as in Work Center here. So we can see posture policy. So you've got two places to access the same thing. And if we locate one of these policies, maybe this one, or this one for Windows, default anti-malware policy Windows. So this policy defines the conditions that need to be met. For example, the operating system, the type of agent, etc., to check for the anti-malware requirements that we reviewed in the previous step. So you can see the conditions here. You can see operating system and all the other conditions here. And we can also optionally edit it from here as well. By the way, agent here, this means the posture type. So this means the endpoint must have a posture agent installed. In modern ISE deployments, this is typically Cisco Secure Client, which is the new name. The old name was Cisco AnyConnect Secure Mobility Client. Without the agent, ISE cannot perform posture checks, for example, antivirus, firewall, OS patch level, and so on. So it needs the agent. And this 4.x or later, this is the agent version requirement. Only endpoints running Cisco Secure Client version 4 or newer will match this posture rule. So that's a quick overview of how devices are postured within Cisco ISE. By the way, I forgot to show you the client provisioning policy. So this will determine what users will receive upon login and user session initiation, as it says over here. So the version of the agent profile, agent compliance module, and agent customization package. And it tells you the type of agents as well, Windows, Mac Temporal, and so on. So you can have a read of this, but the policies are down here. Here's a Linux specific one and here's an iOS specific one. If we close this down, you can see the full policy. When ISE is configured to use an agent, ISE first needs to check if the agent is installed and properly configured before it can perform the posture assessment. If the agent is not installed, ISE redirects the user to a provisioning portal where the agent can be downloaded. So this is really to install the ISE posture module so ISE can do a posture assessment of the devices. You first need the ISE posture agent, the module installed. So these rules have conditions if met. We'll call a configuration profile for the Secure Connect agent. This profile defines the agent version and the ISE posture module version used and the general settings for the agent. So for example, if ISE recognizes that the operating system is Windows, then it needs to push the corresponding software package. But in this example, it's Linux and iOS. And then there's also the client provisioning portal over here. So this is the section where the provisioning portals for posture are configured. You can create new ones, you can edit the existing one as well. And then this is the provisioning portal. Here's the portal settings. It's too much information to go through, but we'll scan through it. Login page settings, acceptable user policy or acceptable use policy. Post login banner after you've logged in, change password settings. And support information page settings, and you've got a workflow on the right hand side as well. There was a workflow somewhere here. Here it is, just to show what the device will go through when going through the provisioning portal workflow. So that's it. That's a high level overview of the posture assessment features. So that brings us to the end of our Cisco ISE course. We've covered how ISE helps secure access, enforces policies, and provides visibility across the network, from authentication with 802.1x, features like MACsec, EasyConnect, and TrustSec. As you move forward, remember that ISE is not just a tool, but a platform to unify security and simplify operation. Thank you for joining, and I hope you now feel a lot more confident applying Cisco ISE concepts in real-world environments.